Present, sir.
Okay. Sadashiv. Sadashiv. Sagar. Sai Prakash.
Present, sir.
Right. Samir Ahmad.
Present, sir.
Okay. Sania.
Present, sir.
Right. Sanjay. Sanjay. Sankalp.
Present, sir.
Okay. Sanket. Shiraj.
Present, sir.
Okay. Shivnanda Natikar. Shraddha. Shraddha. Shubham.
Present, sir.
Right. Sumit. Suraya Banu.
Present, sir.
Right. Tejas.
Present, sir.
Okay. Vivek.
Yes, sir.
Right. Yamunappa. Yamunappa. गांवकर रजत रामचंद्र. मंजुनाथ. प्रथमेश. जोसलिनो. सोहम. अतिया देवलापुर. Atya Devlepur. Okay. Anybody else? Right. In the last class, we were discussing about the fixed bias configuration, approximate hybrid equivalent circuit. Is the screen visible, students?
Yes, sir.
Okay. So this was the topic of the last discussion, approximate hybrid equivalent circuit of fixed bias configuration. And based on this RE model, that is hybrid model, we derived the various equations for Zi, performance parameters, Zi, RB parallel HI, Z0 is RC parallel 1 upon HOE, AV is minus HFE into 1 upon HOE parallel RC divided by HIE, AI is minus EV into Zi by RC, that is approximately beta, that is HFE. Just note down these formulas. We'll be solving an example on this hybrid equivalent circuit of fixed bias configuration. Zi is RB parallel HIE, Z0 is RC parallel 1 upon HOE, EV equal to minus HFE into 1 upon HOE parallel RC by HIE, and AI is equal to beta, that is HFE. Just note down these formulas quickly. Is it noted down? Noted down here?
Yes, sir.
Okay. Then write down this example. For the network of figure below, determine Zi, Z0, AV, and AI. For the network of figure below, determine Zi, Z0, AV, and AI. Note down the circuit also. Note down the circuit. There is C1, RB is 330 kilo ohms, VCC 8 volts, RC 2.7K, C2, HFE equal to 120, that is beta, HIE is equal to 1.175 kilo ohms, HOE that is 20 microampere per volt. HFE 120, HIE 1.175 kilo ohms, HOE 20 microampere per volt. Noted down the circuit. I think everybody noted down the circuit here. Okay. Which circuit is this? Which is this circuit? Which is this circuit? Anybody? Which circuit is this? Whether it is voltage divider bias configuration or emitter follower configuration or fixed bias configuration. Which circuit is this? Fixed bias?
Fixed bias.
Correct. It is fixed bias circuit, fixed bias configuration. Now, when asking the question in the examination, they may ask for the network of figure below, find Zi, Z0, AV and AI. Another way of asking the question is, for the fixed bias circuit, given RB is equal to 330 kilo ohms, RC equal to 2.7 kilo ohm, HFE equal to 120, HI is equal to 1.175 K, HOE equal to 20 microampere per volt, find the value of Zi, Z0, AV and AI. Right? That means it will be clear that it is fixed bias circuit if they mention in the form of a statement. But if they give in the form of circuit, first you have to identify which circuit it is. You have to identify which circuit it is and then start solving the problem. Okay. Now you all have identified that this is a fixed bias circuit. Yes, of course it is a fixed bias circuit. Now let us find the performance parameters: Zi input impedance, Z0 output impedance, AV voltage gain, and AI current gain. Now what all formula just you noted down, use those formulas. Find out first Zi. What is the formula for Zi? RB parallel HIE. RB parallel HIE. RB is how much? 330 kilo ohm. RB is 330 kilo ohm. HIE is how much? 1.175 K. 1.175 kilo ohm. Find out the parallel combination of 330 K and 1.175 kilo ohms. Tell me the answer. $330K parallel 1.175K.
Sir, 1.170K.
Correct. That is HI will be equal to approximately 1.171 kilo ohms. Note down that HIE is approximately equal to 1.171 kilo ohms because RB parallel HIE, RB is 330 kilo ohms and HI is 1.175 kilo ohms. When we take the parallel combination of very large resistance with very small resistance, the equivalent resistance will be equal to the very small resistance. Therefore, here RB parallel HI will be equal to approximately HIE, that is 1.171 kilo ohm. Note down like that. It is approximately equal to HIE, it is 1.171 kilo ohm. All of you are done with this Zi. Zi calculation is done, everyone. 1.171 kilo ohms. Next, what is Z0? What is the formula for Z0? RC parallel 1 upon HOE. Z0 is RC parallel 1 upon HOE. HOE is how much? 20 microampere per volt. 20 microampere per volt. RC is 2.7K. That is 2.7K parallel 1 upon HOE. HOE is 1 upon 20 microampere per volt. Find out the value of the output impedance Z0. First find 1 upon HOE. First found 1 upon HOE, that is 1 divided by 20 microampere per volt. Then next find RC parallel 1 upon HOE. RC is 2.7K parallel with whatever value you are getting 1 upon 20 microampere per volt. And tell me the answer. Use
Sir,
this formula.
2.56.
2.56K, exactly. Z0 will be 2.56 kilo ohms. That is approximately equal to RC. Because 1 upon HOE is more, it is 50 kilo ohms you will get. Am I right? 1 upon HOE you will get 50 kilo ohms. Yes or no?
Yes, sir.
Okay. Therefore, one Z0 will be equal to 50 kilo ohm parallel 2.7 kilo ohm. That will be coming out to 2.56 kilo ohm. That is approximately equal to RC. Approximately equal to RC. Now we found out Zi input impedance and Z0 output impedance. All of you are getting the answers here? Ankita, getting the answer? Ankita?
Yes, sir.
Okay. Chandrasekhar? Chandrasekhar got the answers? Zi and Z0? Janvi? Janvi?
Yes, sir.
Got the answers? Okay. Mahadev? Mahadev? Mohammed? Mohammed? Kirti? Kirti? Got the answers here? Kirti? Prajwal Gowda?
Yes, sir.
Getting the answers?
Yes, yes, sir.
Okay, fine. Fine.
Thank you.
Next, hit down the next formula. AV is equal to minus HFE into 1 upon HOE parallel RC, that divided by HIE. AV is equal to voltage gain is given by minus HFE into 1 upon HOE parallel RC, the whole divided by HIE. Now see the problem statement. HIE is given 1.175 kilo ohms. HFE is given, HFE is 120. Then HOE is 20 microampere per volt. 20 microampere per volt. Minus HFE into 1 upon HOE parallel RC, that divided by HIE. Substitute these values and find the value of AV. 1 upon HOE, just now you calculated. You got it as 50 kilo ohms. 1 upon HOE. Directly you take that. 50 kilo ohms. Parallel with RC. RC is how much? 2.7 kilo ohm. 2.7 K. Then that multiplied by HFE. HFE is 120. This divided by HIE. HIE is how much? 1.175 K. Okay.
So minus,
yes, please.
sir, minus 261.44.
Exactly. Minus 261 or approximately minus 262.34. Okay. Here one slight adjustment we have to do. HIE, whatever we are taking, no, that we have to take it as 1.171 K. That's why I mentioned there. Take it as ZI is approximately equal to HIE, that is a 1.171 K. Here, this one. ZI is approximately equal to HIE, that is approximately equal to 1.171 K. Because this HIE and all, they are the specified values. Okay, they are given by the manufacturer. HIE and all, HIE, HOE, HFE, right? Now, according to our design, we are modifying these values. According to our design, we are adjusting the values. Therefore, we have to take ZI is approximately equal to HI and HI is approximately equal to 1.171 kilo ohm. Therefore, in the gain formula AV, we have to substitute 1.171 kilo ohm instead of 1.175 kilo ohms. They have given it as 1.175 kilo ohms, but we have to take it as 1.171 kilo ohms. Whatever we are calculating, that only we have to consider in the design. In the gain, voltage gain formula, we have to consider the value of HIE as 1.171 kilo ohms. Okay, got the point here? We have to adjust the value. This is given by the manufacturers, these values, but we have to adjust the values according to our design. Therefore, we are substituting minus 120 into 2.7K parallel 50K, that divided by 1.171K, we will get it as minus 262.34. Just verify your answers. Minus 262.34 we will get. Getting the answer, just check. Minus 120 into 2.7K parallel 50K, that divided by 1.171 kilo ohms. Just check this, minus 262.34 you will get. Getting this? Minus 262. Getting the answer? Prajwal Gowda, getting the answer? Prajwal Gowda?
Yes, sir.
Ramesh?
Doing, sir.
Doing? Okay, do it. Ratan, got the answer here? Verify this answer.
Yes, sir. Calculate.
Okay. Rutik Chopde? Rutik? Rutvik Gune?
Yes, sir.
Getting this answer, Rutvik?
Yes, sir.
Okay, fine. Then the last part is current gain, AI, we have to calculate. AI is approximately equal to HFE. HFE is already given in the problem. HFE equal to 120. That is nothing but beta value. Beta is also nothing but HFE, right? In the RE model, we take it as beta, and in the hybrid model, we take it as HFE. That is the only difference. Therefore, HFE equal to 120. Just substitute that. Current gain is approximately equal to HFE. That is approximately equal to 120. We have calculated the performance parameters ZI, R0, Z0, EV, and AI. Is this example understood here? Is this example understood here? Yes. Sai Prakash?
Yes, sir.
Understood this example?
Yes, sir.
Okay, great. Next, we'll go to the voltage divider configuration. Voltage divider bias configuration. Now, this is the voltage divider bias configuration. We know that we have R1, R2 voltage divider, then collector resistance RC, emitter resistance RE, input capacitance C1, output capacitance C2, bypass capacitor CE, bypass capacitor CE, VCC, VI, V0, ZI, input impedance, Z0, output impedance, HI and HFE. Now, in this voltage divider bias configuration, the small signal AC equivalent network will be similar to the approximate, that is the approximate hybrid equivalent circuit for the voltage divider configuration will be same as the approximate hybrid equivalent circuit of the fixed bias configuration. That is, we can see here, this is the approximate hybrid equivalent circuit for the fixed bias configuration. If we go back and see for the fixed bias configuration, this is the approximate hybrid equivalent circuit of fixed bias configuration. We have RB, HIE, right, input resistance, HFE, IB, output resistance 1 upon HOE, R0, then RC, right. Then if we see the approximate hybrid equivalent circuit of the voltage divider bias configuration also, it is same. RB, HIE, input resistance, HFE, IB, then output resistance 1 upon HOE parallel with RC. Now the change is here in fixed bias configuration. If we see the fixed bias configuration, we have RB. right? There is only one resistance, but here we are having R1 parallel R2. In the voltage divider configuration, R1 and R2 will come in parallel. This we have analyzed when we are analyzing in the module 1, is it not? Thevenin's voltage, correct? Thevenin's resistance. So R1 comes in parallel with R2. As R1 comes in parallel with R2, we are replacing the base resistance RB by R1 parallel R2. RB is there in the fixed bias configuration. In the fixed bias configuration, there is RB. This is replaced by R1 parallel R2. This is replaced by R1 parallel R2. That is, if we replace in the voltage divider configuration formula, in the fixed bias configuration, formulas of performance parameters, just if we replace RB by R1 parallel R2, we will get all the formulas of the voltage divider configuration. Here, RB is there, HI is there, HFE, IB is there, 1 upon HOE, RC is there, right? Now, if we look into this circuit, there is RE, there is resistance RE also, but why this RE is not considered? Can anybody make a guess? Why this emitter resistance RE is not considered in the model here, hybrid model, approximate hybrid model? This is same as the approximate hybrid model of the fixed bias circuit. Just instead of RB, you have to replace it by R1 parallel R2. But here, we are not considering this emitter resistance RE. Can you think why this emitter resistance RE will not come into picture here? Why this is not drawn in the hybrid model here? RE, why we have not considered this here? RE should come here, right? This is emitter, this is base terminal, this is collector terminal, so it should come here, right? At the junction of the emitter HIE and the HFE IB, it should come here, RE. But we are not considering that. Why is it so? Because here the value of CE, when we are doing the AC analysis, we are short circuiting the capacitor. We are short circuiting the capacitor. When we short the capacitor, capacitor value, that is resistance, will be 0. Short circuit resistance is 0, open circuit resistance is infinite. Am I right? Therefore, when we are short circuiting this capacitor, resistance will be 0. 0 comes in parallel with 0 ohms comes in parallel with RE. Right? When RE and 0 ohms come in parallel, what will be the equivalent resistance? RE into 0 divided by RE plus 0 is how much? RE into 0 divided by RE plus 0 is how much?
0.
Parallel combination of RE and 0 ohms is how much? 0 only, no? RE is there and 0 ohms is there. RE into 0 divided by RE plus 0. RE into 0 is 0. 0 divided by RE. 0 divided by anything is 0. Therefore, here it will be a short circuit. Here it will be a short circuit. That's why we are not considering the value of RE. Got the point here? That's why we are not considering the value of this emitter resistance RE, because as it's a short circuit here, when it comes in parallel with the resistance RE, therefore the equivalent resistance will be 0 ohms, the 0 ohms. Therefore, as it is a short circuit, and hence the value of RE is not considered in the approximate hybrid model. Got the point here? Therefore, we have drawn this without considering the value of RE. Okay. Now, in this model, we have to find the values of the performance parameters. Zi is given by RB parallel HIE. Fixed bias formula Zi, RB parallel HIE. Just replace RB by R1 parallel R2. RB is R1 parallel R2 parallel HIE. That will give the value of input impedance. Then Z0 is approximately equal to RC, or it is RC parallel 1 upon HOE. Formula for fixed bias configuration. Z0 is RC parallel 1 upon HOE, but output resistance 1 upon HOE. This is our output resistance 1 upon HOE. Right? 1 upon HOE is the output resistance, small R0. This is large as compared to RC. This is large as compared to RC. Therefore, parallel combination of 1 upon HOE and RC, capital RC, will be capital RC. That is what we are getting here. Z0 is approximately equal to capital RC. RC, because 1 upon HOE, that is small R naught, output resistance is very, very larger than RC. Next, gain formula is same, minus HFE into RC parallel 1 upon HOE, that divided by HIE. AB is equal to minus HFE into RC parallel 1 upon HOE, that divided by HI. Same formula as that of the fixed bias configuration, because there is no RB term here. If there was RB term, that would have been replaced by R1 parallel R2. Yes or no? But as there is no RB term, therefore gain formula is minus HFE into RC parallel 1 upon HOE, that divided by HIE. Same it is. Next, let us see the formula for the current gain. If you want to find the formula for the current gain, then we have to consider this two portions here. One is, this is for the load here. If RL is connected, here in parallel with RC between collector to emitter, if RL is connected, then there is RC and RL in parallel at the output section. RC comes in parallel with RL, right? If you are connecting a load resistance RL in between collector to emitter, here we have not considered RL is 0. We'll consider that later, but as far as now, we'll consider that RL is connected between collector to emitter, which is in parallel with RC. That is, RC will come in parallel with RL. This is RC in parallel with RL. Current flowing through load resistance is IL, load current. Then from this RC collector resistance, here the current flowing here is IC, that is the collector current IC. That is what same thing is shown here, IC. Current flowing is IC. Then next is the input section. In the input section we have RB parallel with HIE. RB in parallel with HIE. That is the same thing is drawn here. RB parallel with HIE. HIE is taken as input resistance, that is RI. As we are taking R naught as the output resistance, therefore the input resistance RI here at the input side between the base to emitter terminal. And this is between base to emitter terminal. This is base, this is emitter. It is, this portion is considered as capital RI. Capital RI is HIE. That is, here we are considering RI in parallel with RB. The current that is flowing through here into the base, that is the main current. It is II or IS. This is the main current which is flowing from the base terminal. It is II or IS. Both are one and the same. Either we can take it as II input current or IS. Here we are considered it as IS. Then the current flowing into the base terminal. The current flowing into the base terminal is IB. Here, this current flowing into the base terminal here, that is IB. Getting the point here? That is IB. This current IB. Now we noted down all the currents, right? This is IS, this is IB is there. Okay. Now let us find output current by input current. The formula for current gain is output current by input current. That is, AI is output current. What is the output, final output current? Current through the load, current through the RL. Here, last portion, RL connected. Current flowing through the load is output current. It is IL divided by input current is supply, that is the main current, II or IS. That is IL divided by IS gives the current gain. Now this IL upon IS, it is obtained as, now for this IL upon IS, this is IL, this is IS here. That is IL by IC. That is output current is IL, input current is IC here. IL by IC. Okay, that is written as IL by IC. Then output current is IC, input current is IB. IC by IB into IC by IB into, then output current is IB, input current is IS. IB upon IS into IB upon IS. Note that how we are writing the equation here for current gain. That is, main equation is current gain is output current by total output current by total input current. Total output current is the load current, IL. Total input current is the main input current, II or IS. That is IL by IS. This is equal to, that is, IL is the output current for this portion, input current is IC, that is IL by IC. Therefore, it is IL by IC into output current is IC, input current is IB, right? Therefore, IC by IB into IC by IB, then into output current is IB, input current is IS into IB upon IS. Here. Therefore, IL by IS, that is current gain AI is equal to IL by IC into IC by IB into IB by IS. Now, what is IL by IC? That we have to find out. IL by IC. Now, if you want to find IL by IC, where is IL? IL is this portion, IC is this portion. We have to consider this portion. Now, if we consider this portion here, then the current which is flowing through RC. Okay. Now, current is flowing here, right? That is IC is flowing here. Then the current through RC. How does the current through RC flow? Just look at here. Current through RC is in the upward direction, I naught. Current through RC resistance is in the upward direction, that is I naught. That is positive here, negative here. Current entering positive, current leaving negative. The same is shown here. It is in the upward direction, current entering positive, current leaving negative. That is I naught is equal to IC plus IL. Current flowing through RC, that gets split into IC and IL. That means the current flowing through RC is IC plus IL. Am I right? Current flowing through RC is IC plus IL. Main current I naught is getting split into IC and IL. Therefore, current flowing through RC will be IC plus IL. Let us write the equation here. That is now positive here, negative here, current entering positive, current leaving negative, minus of IC plus IL into RC, minus of IC plus IL into RC. Then take this loop, it's a closed path. Then positive to negative, minus IL RL is equal to 0. What is the equation here? Minus of positive to negative, minus of IC plus IL into RC. Then come to here, closed path, clockwise direction, positive to negative, minus IL into RL is equal to 0. We'll write the equation. The equation is minus of IC plus IL minus of IC plus IL into RC minus IL RL minus IL RL is equal to 0. Now we have to simplify this. What we will get after simplification? Minus IC RC minus IC RC minus IL RC minus IL RC is equal to IL RL is equal to IL RL. IL into load current into load resistance, IL RL. Now, if I take this IL RC to the RHS, what we will get? That is minus IC RC minus IC RC. This will be equal to IL RL plus IL into RC. Okay, that is minus IC RC. This is equal to, I will take IL common, IL into RL plus RC. Now what we want here? We want the ratio of IL to IC, IL by IC. Therefore, IL by IC will be equal to IL divided by IL, this divided by IC, this divided by IC is equal to what we will get? Minus RC. Just rearrange the terms. Minus RC divided by minus RC, this divided by RL plus RC. Okay. Therefore, equation for IL by IC is minus RC divided by RL plus RC. Right? We got one equation. Okay. Let us take this as RL plus RC. It is. Let us take it as equation. Some equation. We'll get a number 1. Equation 1. Then next. IL upon IS is equal to IL by IC into IC by IB into IB by IS. IL by IC we got it as minus RC by RC plus RL, but RL is 0. In our circuit we have not considered RL, so it is 0. Therefore IL by IC will be minus RC divided by RC. RL is 0, RC and RC will cancel. Therefore we will get it as minus 1. Okay. Similarly, you have to find out IC by IB. IC by IB. Okay, IC by IB. Let us see what is IC by IB. IC by IB is HFE. If we look into this circuit here, IC by IB. IC by IB, that is IC is equal to beta times IB. This is the collector current. It is beta into IB. So what is beta? HFE. Beta is HFE. IC will be HFE into IB. That is beta into IB, or beta is equal to HFE. Beta is equal to HFE. In RE model, we write it as beta, whereas in the hybrid model, we write it as HFE. Comparison between hybrid model and the RE model. Therefore, what we have written here, IC by IB is equal to HFE. IC is beta times IB. IC is beta into IB, that is HFE into IB, or IC by IB is equal to HFE. Now, last portion is IB by IS. IB by IS. Now, if you want to find IB by IS, IB by IS, that is this current IB divided by IS. Okay. Now, what is the current flowing through RB? This is the main current, IS, II or IS, main current. This gets split into current through RB and the current through RI. Current through RB and the current through RI. Okay. Now, when it is getting split into current through RB and current through RI, now what is the current flowing through RB? It is positive here, negative here. Current entering positive, current leaving negative. Correct. Now the current flowing through RB is how much? This current is IS, this current is IB. Apply KCL. Tell me what is the current flowing through RB? Current flowing through RB is how much? IS minus IB. Right. This is the main current, IS. The current flowing through RI is IB. Therefore, the current flowing through RB will be IS minus IB. Right. Therefore, the equation will be. That is negative to positive. Negative to positive. Here it is negative to positive. I'll go in the clockwise direction. It is increase in energy. It is my IS minus IB into RB. IS minus IB into RB. Right. Positive to negative minus IB RI is equal to 0. What is the equation? IS minus IB into RB. Then come here, positive to negative decrease in energy minus IB RI is equal to 0. Write it. Let me write the equation. So what is the equation we are getting? Equation is IS minus IB IS minus IB into RB minus IB RI minus IB RI is equal to 0. That is, simplify this, IS RB minus IB RB is equal to IB RI. Okay, IB RI, correct. Now I'll write the equation for IS RB will be equal to IB RI plus IB RB. Okay. That is IS RB will be equal to, take IB common, IB into RI plus RB. Okay. Therefore, write the equation for IB by IS. IB by IS will be IB divided by IS will be equal to just rearrange the terms. IB by IS is equal to this. IS will come to the RHS. It will come to denominator. That is RB divided by RB divided by RI plus RB. Okay. Therefore, IB by S is equal to RB divided by RI plus RB or RB plus RI. This is, take it as equation 2, whatever we have got. This equation, I'm writing it here. That is, IB by S is equal to RB divided by RB plus RI. IB by S is equal to RB divided by RB plus RI. Or IB is equal to IS into RB divided by RB plus RI. Now, whatever we have got IL by IC, that is -1, IC by IB, that is HFE, then IB by IS, that is RB divided by RB plus RI. Just substitute in this equation and find the equation for the current gain. Just you have to substitute. Therefore, AI will be equal to, next equation, IL by IS, main equation, that is -1 into HFE into RB divided by RB plus RI. That is equal to minus HFE into R dash divided by R dash plus HIE. Now, how we got it as R dash? R dash is nothing but RB, that is R1 parallel R2, because we know that RB is replaced by R1 parallel R2, R1 parallel R2, right? That is, I am taking it as R dash. R dash is RB, that is R1 parallel R2. Then RI, input resistance RI. This RI is R1 parallel R2 parallel HIE. This RI, this total resistance, input resistance or input impedance here, that is this RB, that is R1 parallel R2 parallel HIE. RB is R1 parallel R2 parallel HIE. That will be R1 parallel R2, R1 parallel R2 parallel HIE. But we know that R1 parallel RT is R2, R1 parallel R2 is very much larger than HIE. Therefore, the parallel combination of R1 parallel R2 parallel with HIE will be simply equal to HIE, because when we take a parallel combination of very large resistance with very small resistance, the equivalent resistance will be equal to the smaller value, that is HIE here. Therefore, here I have written RI is nothing but HIE, because RI is ZI, that is R1 parallel R2 parallel HIE, that will be approximately equal to HIE, as R1 parallel R2 is very much larger than HIE, and RB is R dash, that is R1 parallel R2. Therefore, I have replaced it RB as R dash. Therefore, the final equation for current gain will be minus HFE into R dash divided by R dash plus HIE. Is it clear here, students? This is understood here? Voltage divider configuration equations. Is it clear here? In today's class, we discussed an example on fixed bias configuration, approximate hybrid equivalent circuit. We have obtained the performance parameters. Then we discussed the voltage divider configuration, voltage divider bias configuration, right? And we have obtained the equations for the performance parameters ZI, Z0, AV, and AI. Okay. Next, in the next class, I'll be picking up the common base configuration. Okay, common base configuration. Then we will derive the performance parameters and we'll solve an example on the common base configuration. That I will take up in the next class. Okay, everybody understood the today's topics here? Yes. Sankalp, is it understood?
Yes, sir.
Fine. Sania, Sania, Sanjay, Sanjay, Shiraj,
Yes, sir.
Mujawar. Is it clear today's topic, Shiraj?
Yes, sir.
Okay. Shubham.
Yes, sir.
Understood, Shubham?
Yes, sir.
Any problem in understanding?
No, sir.
Okay. Suraya Banu?
Yes, sir. Understood, sir.
Understood. Okay. Tejas?
Yes, sir.
Tejas? Clear today's topics, Tejas?
Yes, sir.
Any questions?
No, sir.
Okay. Vivek? Okay. Any doubts here, students? Any doubts here in today's topics? Ankita, any doubts? Ankita?
No, sir. No doubt.
Okay, fine. And in the next class, if possible, I'll take the next class in the today's afternoon, that is around 2:30. I'll take up the class. I'll message you that, right? And we'll take up around half an hour or so. We'll take up a class in the afternoon at around 2:30. Okay. Thank you.